Hey everyone, welcome. Oh, there you go. Welcome to the stream. Yeah. So it's another morning session of today. We're gonna be learning React today. So just a reminder, I do this a little bit before work every morning, about an hour. We spend trying to learn a new framework, and then I gotta jump into my job. But today I figured we'd go through some Redux. Um, Specifically, we're gonna use React. I was debating whether we should use Angular or React, but React seems to pair a little bit better with Redux, and I have some React work coming down the pipeline, so I figured we'll jump into some tutorials today. I think what we'll do first is we'll go through the introduction here. We'll read some of the core principles, learn some of that stuff, and then we'll go into the basic tutorial if we have time. I don't think we'll, depending on how lengthy these articles are, which they seem to be fairly lengthy. No, I guess not. But we'll go through, learn some stuff. So the basic understanding of React or Redux is it's a state management for your app. So I'll go over my understanding of Redux, and then we'll see how it varies throughout what we learned today. So Redux is a state management for your app. You execute actions on a store that holds your state. So for example, if you had, we'll use their example, to-do list with text and completed, you would have a store that would have your to-dos stored in there. Normally what you would do is you would maybe make an API call out to a server and grab, that would be a get on to-dos. You would get all your to-dos back and then you would just load them into the page. But that gets a little cumbersome because you're making a network call out, and that adds a lot of traffic to something that might not necessarily need to get it. So you don't need to retrieve from the server all the to-dos every single time. You may only need to grab them once and then keep reusing them, and that's where Redux shines greatly. One of the other big benefits of Redux is the fact that the data is immutable. So you're executing actions on top of your store. So you basically can track all of it if you wanted to, of like what happened in your app and why your state's in a certain way. So, anyways, jump into it. So let's go with the getting started with React or with Redux. Redux is a predictable state container for JavaScript app. It helps you write applications that behave consistently, run in different environments, client, server, or native, and are best to test. On top of that, it provides a great developer experience such as live code editing, combined with time traveling debugging. That's interesting. You can use Redux together with React or any other Vue library. It's tiny, 2 kilobytes, including dependencies, but has a large ecosystem of add-ons available. So let's look at the basic example. So it has a counter with the initializing the state to 0, and then the actions are what you're executing on. So basically, it's in summary, whenever you're executing these actions, it's just a switch case that modifies the state of your application. So, for example, if you need to increment or decrement something, you would pass the action type of increment in the current state of the app, and it will return you state +1 or state minus, or just the default state. One thing to note is you always have to have a way of returning the current state if an action is not specified, and it shouldn't modify anything. So it looks like they're creating the store. Create store is imported in from Redux, it's standard library, and then using this counter function to initialize what happens with what actions. So then whenever you go to access that store, so let's say you wanted to perform actions on that, you can subscribe using observables, and then just like store.getState, so you can grab the current state. And if you needed to increment or decrement them, you can use this dispatch command. And then see, you can put type as increment, and it would make the state +1. Okay, so let's keep going down through here. I'm not gonna read all of this, but we'll go through. I don't really want to. Core concepts, maybe I should read through. So imagine your app state is described as a plain object. For example, the state of a to-do app might look like this. To-do's array with an object of text incompleted, with properties of text and completed, and then a visibility filter of show completed. This object is like a model, except there are no setters. This is so that different parts of the code can't change the state arbitrarily, causing no hard to reproduce bugs. To change something in the state, you need to dispatch an action. An action is a plain JavaScript object that describes what happened. Here's a few example actions: add to do, toggle to do, set visibility filter. Okay. Sorry. All right. Enforcing that every change is described as an action. Let us have a clear understanding of what's going on in the app. If something changed, we know why it's changed. Actions are like breadcrumbs of what has happened. Finally, to tie state and actions together, we write a function called a reducer. Again, nothing magical here. It's just a function that takes a state of an action as arguments and returns the next state of the app. It would be hard to write such a function for a big app, so we'll write smaller functions managing parts of the state. Okay, so reducers are essentially how to modify the app. And that's what we saw earlier, which was that counter. Well, in the previous example. In this one, it's to-dos. And then visibility filters another reducer. So there's two reducers in this example. Okay. So we write another reducer that manages the complete state of the app by calling those two reducers for the corresponding state keys. Okay. So you have two functions that you can just cascading down through, as opposed to like making one huge switch case statement. You have at least managed a little bit through functions. And we write another reducer that manages the complete state of our app by calling those two reducers for the corresponding keys. Yeah. So basically the whole idea is Redux. Note that we haven't used any Redux APIs. It comes with a few utilities to facilitate this pattern, but the main idea is that you describe how your state is updated over time in response to action objects. And 90% of your code you write is just plain JavaScript with no use of Redux itself, its APIs, or any magic. Yeah. Okay, so 3 principles. These are the important things to have in any Redux thing. Single source of truth. The state is your whole application is stored in an object tree with a single store. This makes it easier to create universal apps, as the state from your server can be serialized and hydrated into the client with no extra code effort. A single state tree also makes it easier to debug or inspect an application. It also enables you to persist your app's state in development for a faster development cycle. Some functionality which has been traditionally difficult to implement, undo, redo, for example, can suddenly become trivial to implement if all your state is stored in a single tree. Okay, that makes sense. Okay, so it's important. Okay, into one whole object tree. Okay. See, I had understood that you could make multiple stores to store your information in, but apparently you can make different properties of a single object to store everything in, but it needs to be one massive object. That's your app state. State is read-only. The only way to change the state is to emit an action and an object describing what happened. This ensures that neither the views nor the network callbacks will ever write directly to the state. Instead, they express an intent to transform the state. Because all changes are centralized and happen one by one in a strict order, there's no subtle race conditions to watch out for. As actions are just plain objects, they can be logged, serialized, stored, and later replayed for debugging and testing purposes. Okay. The dispatch complete to do, index 1, dispatch set visibility filter to show completed. Changes are made of with pure functions. Okay, so this is the third principle. The second principle was state is read only. The third principle is changes are made with pure functions. Specify how state tree is transformed by actions. You write pure reducers. Reducers are just pure functions that take the previous state and an action and return the next state. Remember to return new state objects instead of mutating the previous state. You can start with a single reducer and as your app grows, split off into smaller reducers that manage specific parts of the state tree. Because reducers are just functions, you can control the order in which they are called, pass additional data, or even make reusable reducers for common tasks such as pagination. Okay, so that's a good path to know. So they're basically saying well, they're not saying this, they're saying a good way of doing this is make a large reducer for what you need to do first, and then start breaking it into little smaller components as your app matures a little bit. Okay. And by the way, pure functions are functions that have no side effects. So a side effects would be something like writing to disk I/O or modifying some external dependency other than what's scoped to the function. So any parameters into a function should always return the same parameters to a function should always return the same result. That's a good way of understanding if it's a pure function or not. So if I was to run that application and pass the same parameters from the ground up, you should be able to see the same results or have a predictable manner of what those results are. All right, so let's look at this visibility filter to-dos, and then we're getting nested in the action types. And then, what is this? Combine reducers. Oh, okay. So that's a nice way of making your parent reducer. You can use its combine reducers and then put it into your parent store. Okay. Prior art. I'm not going to read RSJX. Okay. Learning resources. Those are all videos, though. Okay. Let's jump into the basic tutorial and let's see where that goes. Okay, so the basic tutorial intro. Okay, so the tutorial is going to make a to-do app. Jump into that. So first, let's define some actions. Actions are payloads of information that send data to your application from your application to your store. These are only sources of information for your store, for the store. You can send them using store dispatch. Are they gonna let us install it, or are they just jumping straight into it? Seems like they're jumping straight into it. Okay, so first off, let me install Redux. I did make a project already. Oops. CD Redux tutorial. Tried to alleviate some of the npm package install, but can't get it all. I don't think we'll need this yet. We'll just keep that in mind if we need these. The React Redux and Redux Dev Tools. Nice, okay. So we'll do app.js, and then we're gonna do something like this. Store. We'll do. All right. Whoops. Actions. Okay, first off, let's define some actions. Actions are payloads of information that send data from your application to your store. They are the only source of information for your store. Send them using the store.dispatch. Here's an example action that represents adding a new to-do item. So add to-do is just constant string, and then a payload of add to-do with text build first React app. Actions are plain JavaScript objects. Actions may have a type property that indicates the type of action being performed. Types should typically be defined as string constants. Once your app is large enough, you may want to move them into separate module. Okay. Other than type, the structure of an action object is really up to you. If you're interested, check Flux standard action for recommendations on how actions can be constructed. What is Flux, though? Is Flux? What is Flux? Redux, what is Flux? In Redux, the convention is to have a single store per application. Flux is a single dispatcher for all actions passed through the dispatcher. Flux is a fancy name for the observer pattern, modified a little bit further to fit React, but Facebook released a few tools that aim in implementing the Flux pattern. So following the difference between these tools, which is commonly referred to in using Flux, is using Redux. Okay. Both Flux and Redux have actions. Actions can be paired to events. With Flux, it is convention to have multiple stores per application. Each store is a singleton object. In Redux, the convention is to have one single store per action. Okay. So, okay. That makes sense. So what I was thinking Redux was actually Flux. We can have multiple stores per application. Okay. We'll add one more action type by describing a user. Lower this a little. There we go. All right. We'll add one more action type to describe a user ticking off a to-do as completed. We'll refer to a particular to-do by index because we store them in an array. In a real app, it's wiser to generate a unique ID every time something new is created. Okay, so toggle to-do index 5. You're going to do to pass little data in each action as little data in each action as possible. For example, it's better to pass the index rather than the whole to-do object. So basically patches, if you're familiar with REST. Finally, we'll add one more action type by changing the currently visible to-dos. Okay? Action creators. Action creators are exactly that. Functions that create actions. It's easy to complete the terms actions and action creators. So to do your best to use the proper term. In Redux, action creators simply return an action. Okay. Okay, so you can create your own actions, or you can create a function to create your action. If you have a complex action a little bit. So this makes them portable and easy to test. In traditional Flux, action creators are often trigger a dispatch when invoked like so. So to do with dispatch, do this. Oh, so you can basically create that function that creates the action, dispatches it, where you're just passing the text object. That makes sense. I like that. In Redux, this is not the case. Oh. Instead, to actually initiate a dispatch, pass the result of the dispatch function. So add to do and complete to do. Okay. Alternatively, you can create a bound action creator that automatically dispatches. Um, what's the matter with doing these two? Like, I'm still confused on like why this isn't a good practice. Okay, a bound action creator that automatically dispatches. But that's the same. This is the same as this. And like, if you're saying that this is because this is returning, you could add a return keyword there. It's just this is shorthand, I guess. Okay. Well, regardless, let's keep moving. Now you'll be able to call them directly. Bound add to do text. The dispatch function can be accessed directly in the store as store.dispatch, but more than likely you'll be accessing it using the helper like React Redux's connect. You can use bind action creators to automatically bind many action creators to a dispatch function. Action creators can also be asynchronous and have side effects. You can read about async actions in the advanced tutorial and learn how to handle AJAX responses and compose action creators into async control flow. Don't skip ahead to async actions until you've completed the basics tutorial, as it covers other important concepts that are prerequisites for the advanced tutorial and async actions. Okay. So actions.js. We'll basically add these two. I'm gonna go ahead and add this real quick. So let's go ahead and actions.js, and then from here, I'm gonna review it, but I'm just gonna steal the code. So we have three constant actions: add to do, toggle to do, and set visibility filter. The other constraints are the visibility filters are show all, show completed, and show active. So these are the three actions we're performing on the state, and these are three types of actions that you would be setting the visibility state to. So action creators are add to do, which would basically construct the type of add to do and then pass text, the type of toggle. So these are creating our three action types. And then also, based on what parameter we pass in, we are setting that as well. The next steps now, so let's define some reducers and specify the state updates that data. The reducers specify how application's state changes in response to actions sent to the store. Remember that actions only describe what happened, but do not describe how application's state changes. Designing the state shape. In Redux, all the application's state is stored in a single object. It's a good idea to think of the shape before writing any code. What's the minimum representation of your app state as an object? For a to-do app, we want to store two different things: the currently selected visibility filter and the actual list of to-dos. You'll often find that you need to store some data as well as some UI state in the state tree. That is fine, but try to keep the data separate from the UI state, like the visibility filter I see. Okay, so these would be an example of our store. More complex apps, you're going to want different entities to reference each other. We suggest that you keep your state as normalized as possible without any nesting. Keep every entity as an object stored with the ID as a key and use IDs to reference it from other entities or lists. Think of the app's state as a database. This approach is described in normalizer documentation in detail. For example, keeping to-dos by ID and to-dos array ID inside the state would have would be a better idea in a real app, but we're keeping the example simple. Handling actions. Now that you've decided what our state object looks like, we're ready to write a reducer for it. The reducer is a pure function that takes a previous state of the action and returns the next state. It's called a reducer because it takes the type of function that you would pass reduce. It takes the reducer because it takes the type of the function you would pass to array prototype. It's very important that the reducer stays pure. Things you should never do inside the reducer: mutate its arguments, perform side effects like API calls, and routing transitions. Call non-pure functions like date now and math random. So we would have to pass those in as parameters if we wanted something with a date on it. Okay, we'll explore. We'll explore how to perform side effects in an advanced walkthrough. That's always been a gray area to me, is making API calls to initialize your state in your app, or to keep your app's state up to date. Another thing. For now, just remember that the reducer must be pure. Given the same arguments, it should calculate the next state and return it. No surprises, no side effects, no API calls, no mutations, just a calculation. With this out of the way, let's start writing our reducer by gradually teaching it how to understand the actions we defined earlier. We'll start by specifying the initial state. Redux will call our reducer with the undefined state for the first time, and this is our chance to return the initial state of our application. So let's go ahead to give us a state at the bottom. Yeah, okay, it's going to give us all of this at the bottom. I'm just going to keep reading, and then we'll grab it at the bottom. So visibility filters, initialize state, visibility filter, show all, to-dos, app to-do, undefined. So basically, we're making a default state here, and then the to-do app state and action. So this would be our first reducer. And if the state is undefined, it'll return this just default state. Okay. One neat trick to use in ES6 default argument syntax is to write it in a more compact way by setting it equal to in the parameter. Let's handle the set visibility filter. All it needs to do is change visibility filter on state. Easy. So if we pass in the action type of set visibility filter, we will object assign state visibility filter to action filter. So why wouldn't we? Oh, because we're making a new object. Okay. So we're using the object assign because we want to construct a new state and then pass it in instead of modifying the old state. So if we were to take state dot visibility filter and set it equal to action dot filter, so if we took this guy, we would be modifying the parameters state because it's passed by reference. So we have to use this object dot assign, construct a new object, and then take the previous state as the base for it, and then assign it the new properties that we want to change. Then we return our default state. Okay. Oh, so they're going to reiterate what I just said. Nah, we don't mutate the state. We create a copy of the object assign. Object assign state visibility filter is also wrong. It will mutate the first argument. You must supply an empty. Okay. Wait. Oh yeah. Okay. Yeah. So never mind. It's not what we were saying wasn't wrong. It's just saying object assign with the state first one in the filter is also wrong. It will mutate the first object. You must supply an empty object as its first parameter. You will also enable object spread operator proposal to write a state new state instead. So if we wanted to, we could spread out the initial state and assign it to a new state. So we'll return the previous state in the default case, it's important to. So basically, what they were saying with the spread operator is we could have taken an empty object and then spread out the existing state, which will assign all of its properties and all of its child objects to that empty object as new properties. And then if we do new state as the second argument, it'll actually replace over top of it the new state. We return the previous state instead of in the default case. It's important to return the previous state for any unknown actions. Note object assign. It's ES6. We'll need to use polyfill if you want to use it. So if you're using any browsers that don't support ES6 or any frameworks that don't support ES6, that will not work. Okay. Handling more actions. We will have 2 more actions to handle, just like we did with the set visibility filter. We'll import the add to do and toggle to do actions, and then extend our reducer to handle add to do. Okay. So we're just importing the add to do and toggle to do from our actions, and then the to do, and then basically making the reducers for those actions. So it seems like this is the one we did prior. Now we're going to take, maybe I should do this a little bit more visible. So, what was this name? Oh, so add to do. So we're doing the same thing. We're reduce object assign state and then basically making the array state to do. We're using the spread operator on the existing to dos to spread them out, and then adding our new one. Okay, that's interesting. Well, it's good practice. I just didn't think of that. Just like before, we will never write directly to the state or its fields, and instead we'll return new objects. The new objects is equal to the old to-dos concatenated with a single new item at the end. The fresh to-dos was constructed using the data from actions. Finally, to implement the toggle to-do handler, the implementation of the toggle to-do handler shouldn't come as a complete surprise. Toggle to-do, oh yeah. So the toggle to-do, basically, we're taking states, we're doing the object assign, we're taking the state, and we're constructing a new state with the to-dos property, and then taking state.todos.map, and then taking each of the to-dos in there, in the index, checking if the action.index matches that index. So if this was a more complex or more finalized system, this would probably be ID and ID. It would be to-do.id is action ID, and then reconstruct the object assigned with that to-do from the array and toggle the completed flag. So that's a complex way of basically looping through, finding your to-do that matches your index or ID and changing its state itself, and you're creating a new object when you're changing the child objects, or the object in the array, the to-do object in the array's state. So you want to construct a new object if you have to modify one of the elements in the array. Because we want to update a specific item in the array without resorting to mutations, we will have to create a new array with the same items except the item at the index. With the same items except the item at the index. If you find yourself often writing such operations, it's a good idea to create a helper like immutability helper updeep, or even a library like immutable that has native support for deep updates. Just remember to never assign anything inside the state unless you clone it first. Okay. Splitting reducers. Here's our code so far. It's rather verbose. I mean, that makes sense. So this is all the stuff we reviewed above. Is there a way to make it easier and to comprehend it seems like the to-dos and the visibility filter are updated completely independently. Sometimes state fields depend on one another and more consideration is required, but in our case, we can easily split updating to-dos into a separate function. That's okay. So to-dos, we're going to switch into its own reducer, and it has its action type of add to-do, and then it does the same stuff, and then toggle to-do. And then in the main reducer, the to-do app, we have the set visibility filter. Yeah, we have the set visibility filter, which is the same. And the add to do now passes the function of to dos, the reducer from above, as the property of that. So you're just grouping them a little bit better. You're doing the same for toggle to do since they exist in another to do. That way your parent switch case statement is not as verbose. Okay. Note that to-dos also accept state, but state is an array. Now to-do app gives to-dos just a slice of the state to manage, and to-dos know how to update that slice. This is called reducer compensation, and it's a fundamental pattern of building Redux apps. Okay. So below imports, let's take ES6 object deconstruction to declare show all. What is show all again? Oh, so show all is another one of our actions, the visibility filter. Okay. So now we can rewrite the main reducer as a function that calls the reducers managing parts of the state and combines them into a single object. It also doesn't need to know the complete initial state anymore. It's enough that the child reducers return its initial state when given undefined at first. So that would be... Where was that? Oh, right here. Okay. So we're breaking out both to-dos into a separate reducer and visibility into a separate reducer, and then assigning both of those reducer to the parent reducer, which is to-do app, and that's the entire application state. So this is a way of cleaning it up a little bit better, in a way that we don't have to have some crazy nested switch case like this one. So like this one, we have 3 switch case and then duplicated switch cases right here. We can now go down to this one, which basically you're just taking the property assigned to whatever the reducer returned, because it's because by default it's returning the initial state. That makes sense. Okay. Note that each of these reducers is managing its own part of its global state. The state parameter is different for every reducer and corresponds to the part of the state it manages. This is already looking good. Okay, yeah, read that. Okay. Oh, so combine reducers. Let me read that. Finally, reducer provides a utility called combine reducers that does the same boilerplating logic that the to-do app above currently does. With help, we can rewrite the to-do app to look like this. Okay, so we can actually, instead of doing this, we can take it even one level deeper and use this combined reducers that Redux provides for us. That's nice. Yeah, yeah. Okay, that's cool. So that way we can make in our parent state app, we can each of our objects that we're working on, we can nest them and use this combined reducers as a way of cleaning it up and making it a little bit more readable and not verbose. You could also give them different keys or call functions differently. These two parts, or these two ways to write a combined reducer are equivalent. Yeah, we're saying the same. This is saying the same stuff. Okay, so let's take this source code. I'll review it again. What is this? Reducers.js. Reducers.js. Okay. So now we have all of our reducer actions. So toggle to do, add to do, set visibility filter, and then getting the visibility filters. Oh, and then the um, types of visibility filters, like show all. And then we're initializing all of our reducers in here, and we're using the combine reducers as our last one to concatenate them together. Cool. Let's go to the store next. I keep checking chat, so just in case anyone has any questions or anything, please ask them, because I will answer them if I can. So, if not, I'm just basically talking to myself. But hopefully this is helping. In the previous sections, we defined the actions that represent the facts about what happened, and the reducers that update the state according to these actions. State has an object that brings them together. The store has the following responsibility: holds the application state, allows access to state via get state, allows state to be updated via dispatch, and registers listeners via subscribe. Oh, I said that like that was the last one. Handles registering of listeners via the function returned by subscribe listener. It's important to note that you'll have a single store and a Redux application. When you want to split your data handling logic, you'll use reducer composition instead of many stores. Let's see. Splitting. Oh, okay. So what we did before, where we split them into small nested child objects and then compose them into one bigger one, or one parent one. There's a hawk outside, actually. Wow. Sorry that distracted me. I was like, that is a big bird. The hawk that flew in my neighbor's yard. Okay. It's easy to create a store if you have a reducer. In the previous section, we used combine reducers to combine several reducers into one, and now we'll import it and pass it to create store. So we have to do. Oh, so we're just returning the parent function into the create store so we can get to going. You may optionally specify the initial state as a second argument to create store. This is useful for hydrating the state of a client to match the state of the Redux application running on the server. You may optionally specify the initial state by argument. Okay. But that state from server seems like that would have to be like a combined massive object. Like if it's initial state from server, it would have to be like the to-dos. Like let's say you had to-dos, tasks, and reminders or something, right? Those three. You would have to make the state from the server would have to be the initialized UI state and those three actions that basically load the data. I know we're going to get into more advanced stuff later, but that seems like a lot. Anyways, a lot to combine together just to initialize it. I mean, it makes sense, but now that we have a created store, let's verify our program works. Even without any UI, we can already test the updated logic. Okay. We didn't make a store though yet. Oh, there it is. Well, I guess I didn't have to. I didn't have to make a Redux application for this, but let me actually, let's go ahead and well, I have to make a packages JSON file, so maybe it is better to do this. I don't want to do this in index though. I'd rather do an app. Right? Okay, so let's do an app. And then, okay. see. Whoops. So we create our store, get the state, and then let's subscribe. Just do these. Let's do exactly what the app says, and then let's do npm start. See what we get. Well, shoot, I should have done this too. Ooh. Oh, okay, so actions needs to be, oh, just slash store, sorry, dot slash store, actions. Then this needs to be the same, slash store, because I nested them one folder for cleanliness. See what happens. Nice, okay. There's my cool React app. Here's all my state. So there's an initial state with an empty array. Then we executed a, well, first off, we're subscribing. Oh, so we subscribe to it, so we can unsubscribe later. Wait, what? Oh, okay, so I doubled up on everything. Hang on. It would have helped to look at the fact that this was logging everything that happened in these state. So let me get rid of that. So yeah. Okay, so we get our initial state, which is nothing, right? Then we do a store.dispatch to do learn more actions, which gets the state. So we added to do for learn more actions. So this should be, yep, learn more actions complete false. And then we keep going down through, added 3 more, and then we toggled the to-dos from 0 to 1. Oh, so we toggled the to-do of the first and second item, so actions and reducers. And then we set the visibility to show completed. So let's expand all of these. See what happened. You can go away there. All right. So at the bottom, we can see we set the visibility to show completed versus show all, which is what it was before. And then we toggled the first and second one here. So this went from false to true. And then from here it went false to true as well. And then that's the final state. Okay, cool. Nice. That's just working. Oh, shoot. Like they display it all for us. Great. Great. All right, data flow. And I got 10 more minutes before I have to jump off, but see if we can get through some of this other stuff. Data flow seems like a decent one using React. That seems like a decent one. Example to-do list. Okay, so we might not get to these last two, but let's try to get through data flow. Redux architecture revolves around strict unidirectional data flow. This means that all data from an application flows the same lifespan or lifecycle pattern, making the logic of your apps more predictable and easier to understand. It also encourages data normalization so that you don't end up with multiple independent copies of the same data that are unaware of one another. If you're still not convinced, read motivation in the case of Flux for compelling arguments in favor of the unidirectional data flow. Although Redux is not exactly Flux, it shares the same key benefits. The data lifecycle in any Redux app follows these 4 steps. Call a dispatch action, store.dispatch.action, or with action. An action is a plain object describing what happened. Yep, so we know that. An action is a very brief snippet of news. Mary liked Article 4 or read Redux docs. It was added to the to-do list. The Redux store calls the reducer function you gave it. So instead of modifying the state directly, it calls the function, or the reducer function. The root reducer may combine the output of multiple reducers into a single tree. So that would be for organization purposes. And then the Redux store saves the complete state tree returned by the root reducer. Okay. The Redux store saves the complete state tree returned by the root reducer. Yep. Okay, using with React. Okay, that's cool. So now what we just learned was the pattern in JavaScript. Not necessarily, like we could have ran that outside of React and it would have done the exact same thing. We would have needed it to be something that can run in Node, but we could have just made a JS object and ran it with Node. From the very beginning, we need to stress that Redux has no relation to React. You can write Redux apps with React, Angular, Ember, jQuery, or vanilla JavaScript. That said, Redux works especially well with libraries like React and Deku because they let you describe UI as a function of the state. And Redux emits state updates in response to actions. We will use React to build a simple to-do app to cover the basics of how React and Redux works. So this is going to build the whole React app using it. So we're just going to review this. I'm not actually going to, we're going to review the code and look what they're doing and not build it. So they're creating a components folder and putting a to-do.js in here, which this will be a component, obviously, for the to-do object. And then they're just passing in some parameters for okay, this is just a function that's returning establishing the props as on-click completed in text and then passing back an li that registers the on-click styles the text with whether it's completed or not, so like a line through it or not, and then registers the text in an li object as well. And then the prototypes, it's just to-do.prototypes, it's setting whether those things are required, which they all are. Okay, that's cool. I didn't actually know about this. I didn't know you could do this. So you're basically setting the object, the prop types, and declaring some validation on top of them. So you're saying prototypes is a string and it's required, prototypes has to be a boolean and it's required, and prototypes has to be a function and it's required. So it's a way of enforcing that the parameters coming into your function are what you're expecting. So that makes sense. So then we're making components.to-do list to hold all of those to-do objects. And then we're passing in the array of to-dos in the to-do click on to-do click. So, and then this is just a UL element, and then we're doing to-dos.mapped to-do with index, and then registering that component of to-do and passing the data down through as we need it. And then we're doing the same thing with the prop types. And for that, we're saying it's an array of prop type shape. Okay, so that's cool. I did not know I didn't even know this was a thing. I've seen it a bunch, but I never really took the time to learn what it was. But apparently, so prop types is something that we can register on each object and expect our parameters. So in this one, we're nesting 2 levels deep. So we're saying it has to be an array and it has to shape like this. I wonder if you can declare an explicit type like with TypeScript, like a class or an interface or something. I wonder if you could do that. Like you could say this needs to be an array of this interface. But I guess it wouldn't have the is required. It's interesting. I'll have to read on that. Okay, so then we're making a third component for links.js, and a link is taking in a property of active children and on click, and then returns a span with the children text. And then if it's active, it will. If not, it will return a link with the on-click registered to whatever you pass it through with, again, the children text. And then again, this needs to be a bool. The children needs to be a node. And then the on-click needs to be a function. What is that? What is the node? This is a link, huh? That's interesting. I'm not following. Like, I just don't know what that is, so we'll just have to keep moving. And then a fourth component for footer, and then we're just registering filtered links. Wonder if these are supposed to be links. No, they're not. Okay. Is this containers? We didn't make that, right? Where the hell did filtered links come from? Oh, okay. This is stuff I should have, I guess, read a little bit. And is it up here? No. It's current visibility. Okay, whatever. It seems like stuff that we were supposed to read, but we didn't. Implementing container concepts. So this is where we're actually going to attach to the store. This is the state or the Redux store. Let me read this. Implementing container components. Now it's time to hook up these presentational components to Redux by creating some containers. Technically, a container component is just a React component that uses store.subscribe to read part of the Redux state tree and supply props to presentational components it renders. You could write a container component by hand, but we suggest instead generating container components like React Redux Library Connect function, which provides many useful optimizations to prevent unnecessary re-renders. One result of this is that you shouldn't have to worry about React performance suggestion of implementing should component update yourself. To use Connect, you'll need to define specific functions, a specific function called map state to props that describes how to transform the current Redux store state into props that you want to pass to a presentational component you are wrapping. For example, visibility to-do list needs to calculate to-dos and pass to the to-do list. So we defined a function that filters the state.todos according to the state.visibility filter, and we use it in its maps state to props. So map state to props is basically taking that function and mapping it to whatever data we need to render in the view and assigning it to the props object so that it can be used in the view. Okay. In addition to reading the state container components and dispatch actions in a similar fashion, how much more do we have? We may have to stop there. Okay. Well, I do have to stop there, so I have to jump on to actually get some work done for my job. That's what pays the bills. So thanks everyone for watching, and if you have any questions, let me know. I know this is a little bit dry sometimes, but that's kind of the concept. I want it to be long form, and I don't want to pull the curtain behind anything that's going wrong or try to just make everything work smoothly. That's one of the biggest things that I see in a lot of tutorials is you see everything that goes right and everything's perfect, pristine, and I mean, it makes sense, but this is kind of supposed to be a format of we're going to go through the highs and lows together. So sometimes I'm just going to be reading documentation, but anyways, I will post this to YouTube. But thanks for watching, everyone.